Assalamu alaikum.
Walaikum assalam.
So today we're going to be continuing with the topic of power. We began yesterday. Today we're going to be looking at a bit of more challenging questions. So for recap, for those of us might have forgotten what power is all about, we have three different equations. We have P is equal to your work over your change in time. This is the main one that we use. We had the other two formulas are derived from. That's our first equation that we use. Then we use our second equation, power equals to your force multiplied by your displacement all over your time. And finally, we have P is equals to, the power is equal to your force multiplied by your velocity. Okay, so did everyone manage to do yesterday's homework?
Yes.
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 Okay. So now I carefully went in to make a new diagram, same diagram, just more colorful and easier to understand. And everything is on this one page, right? So who wants to read the question first?
It's question 10, right?
Yeah.
Okay. A chairlift carries two skiers up a mountain at a constant velocity of 27 kilometers per hour.
Wait,
The
stop
average
there.
mass of the skier. Okay.
Okay, so now the second they tell us constant velocity, we need to remember our equation delta EK. So now if we have constant velocity, straight away we must be thinking our change in velocity is going to be zero. So it will help us, if we have that back of our minds, it will help us in a further question coming in potentially, right? And then can you see, he said 27 kilometers per hour. So now when we see units of measurement such as kilometers per hour, we rather change it into a usable unit of measurement in an equation. So straight away, you also want to start thinking about how to change the 27 kilometers per hour into something such as meters per second. Okay, Jimmy, carry on.
Okay. The average mass of a skier and equipment is 80 kilograms, and the mass of the chair is 20 kilograms. The motor which drives the chair does 1,6 times 10 to the power 6 joules of work over the 1,250 meters of cable over which the chair moves. The amount of work against the friction is 7.1 times 10 to the power 5 joules. Calculate 10.1, the height to which the skiers are carried by the chairlift. 10.2, the instantaneous power delivered by the motor of the chairlift.
Now, make sure you'll have a diagram if you all want to. It's easier to use a diagram because everything is there on that one page, right? Okay, so now 10.1. Now, usually there's two ways to do this. One way is the WNC way here, and the other way is the way that I prefer, which is our WNet way. So I couldn't figure it out to the WNet way, so I was forced to learn the WNC way, which was much easier, I'm not going to lie. So now our work, our WNC is equal to delta EK plus delta EP. That's an equation that we will find on our, we won't find on our formula. We will find it on our formula sheet. So now what's it made up of? Our two non-conservative forces, which is our work from the motor, which is 1.6 times 10 to the power 6 joules, and also the work of friction, which is 7.1 times 10 to the power 5 joules. Then we have, we extrapolate our delta EK and delta EP, give us our half mv final squared minus v initial squared, plus our mg is into your final height minus your initial height. Now, we have all of the data in our diagram. If you'll draw a diagram, if not, it's not a big problem, as long as you know that these values exist. So either you can do a diagram or you can do your data set. So now simple things, we start substituting into the formula. Our work from our motor is 1.6 times 10 to the power 6 joules. It's This here, as you can see, a very nice looking motor in a very detailed diagram. Call me Picasso. Right. Then we have our work of our friction, which is 7,1 times 10 to the power of 5. As you can see here in the red, it's going in the opposite direction. And then we have our constant velocity. So we don't have to even take this into account anymore, because why? Earlier we said delta EK is going to be 0. Why? Constant velocity. Then we start substituting all of our masses. We know there's 2 skiers. Each one is 80 kilograms, 80 kilograms, 80 kilograms, and then this seat itself is 20 kilograms. So we add all of those together to give us our mass. Then we have our gravitational constant of 9,8, and then we left with our H final, which is basically your H, because our initial height was 0. So then it's simple calculator work. You just place all of this into your calculator. You should come out to 890,000 equals to 1,764 H. We divide both sides by this 1,764 H to get our H alone, which will give us 504,54 meters. How did you all find it? Did you all get it right? People?
Yeah, this is a good way of explaining it.
Okay, so can I move on to the next one? Did you all write this down?
Yes.
Yep.
Everyone take this down.
Just 1 second, AK, please.
AK,
Okay.
how do you convert from kilometers per hour into meters per second?
I'm going to do that in the next step, right? In the next part.
Okay. Okay.
Chef, you can move. Thanks.
Yeah, we didn't need it for the sum here yet, but it's just something that you do. Actually, you'll have to do it in the next part, right? Okay, just tell me when everyone's done with 10.1 first.
I'm done.
Where the go ahead from everyone else?
Yeah.
Yes.
Yeah.
Okay, now at 10.2, it asks for the instantaneous power delivered by the motor or the chairlift. So now remember, Ziada just asked, how do I convert this 27 kilometers per hour to meters per second? Like this. So the first thing you do is you write your kilometers in terms of meters. So that's going to give us, you multiply your 27 times 1,000, gives us 27,000. Now to convert from hours to minutes, we divide by 60. And then to convert that to seconds, you have to convert it, you have to divide it by 60 again. So that 60 times 60 is your 3,600 here. Are you following?
Yeah.
Yeah.
Okay.
Yeah.
That's how we get our 7,5 meters per second. Now we look back at the question, see what does the question want? It wants power. So now in our power equations, we can use 2 equations basically, right? The 2 main ones. P is equals to W over delta T, or we can use power is equals to force times velocity. So now which one will be easier for us to find? The time which they give us no data for, or we can find the velocity, or we can find the force. They give us the velocity how? In the 27 kilometers per hour. Yeah, and our V is at constant velocity, just to remind you again, right? So now we have our work, we have our distance traveled or our displacement, which is delta x, and we have our cos theta, which is going to be cos 0. Because why? It's in the direction of motion. So now we go back here. We substitute our values that we know. Our work applied is 1,6 times 10 to the power of 6 joules. We don't know our applied force, but we do know our distance traveled is 1,250 meters. And then once more, the cos of 0, because the same direction of motion there, right? So we substitute this. Are you all following?
Yeah.
Yeah.
Anyone? No one? Okay. So we solve for our F, we get 1,280 newtons. Right? Everyone there? Okay.
Yeah.
Now we finally get to solve
Yes.
for the question, which is power. Now we're using the equation P is equals to FV. Our F is what we have solved for, and our V is what we have solved for earlier. Remember, 7.5 meters per second. Multiply them both out, you get 9,600 watts. Don't forget your unit of measurement. It can cost you big time. Trust me. Okay. So now we have question 11. Who wants to read question 11?
Okay. A truck of mass 5,900 kilograms accelerates from 0 kilometers per hour at the top of a slope to 32.4 kilometers per hour at the bottom. The slope is 360 meters long and the truck starts 45 meters above level ground. The average frictional force on the truck during the journey down the slope is 2.87 times 10 to the power 4 newtons.
Okay.
11.1. Okay.
Okay, let's first take in whatever the question asked for so far, right? So far, the question gave us specific data values. Now, a nice way to do this again is either you write down your data set or you throw a diagram. Okay, so long, I'm giving you like 2 minutes, write down whatever you want. You can copy my diagram, but it's not very creative. It's very bland. Make sure you have all of your data values that they asked you for. Another thing to consider, remember in the previous question, you gave us kilometers per hour again. Before this, I mean, so now they give us 32.4 kilometers per hour again. So if you want to change that kilometers per hour into meters per second, you can do it from the starting again, just so that you have it available. So who wants to tell me what to do with the 32.4 kilometers per hour? Nobody? Okay, we're moving to 10.1, okay? Okay.
Must I read?
Yeah, please.
Okay. How much potential energy does the truck have at the top of the slope?
Okay, so
Let's carry on reading.
let's tackle it one by one, right?
Okay.
So if you look at 11.1, asking us for potential energy. Now, during our entire time doing work, energy, and power, we always knew potential energy's equation to be EP is equals to mgh. The potential energy is equals to your mass multiplied by your gravitational constant multiplied by your height, right? So now we have values given previously. If you look here, we have our mass 5,900 and we have our height. So we have enough information available to us to tackle the question head on. So we just substitute all of the values into the formula. We get our value of 2,600. 2,601,900. I swear I'm not illiterate. Okay. Did everyone get that?
Yes.
Are you
Yes.
writing all of this down, right?
Yeah.
Okay. Can we tackle 11.2?
Yeah.
Calculate the increase in kinetic energy of the truck.
Okay, so now increasing kinetic energy is our delta EK. So what do we need for our delta EK formula? We need our mass and we need our change in velocity. So now in the question it tells us it accelerates from 0 kilometers per hour, which is the same as 0 meters per second, or we can say even it's the same as saying from rest. And it accelerated downwards to reach a final velocity of 32.4 kilometers per hour. So now we need to tackle that kilometers per hour problem again. 32.4 kilometers per hour is equal to 32,400 meters per hour. And then we change this meters per hour. What do? We divide it by 60 times 60, which gives us 3,600. That gives us 9 meters per second to be our P final, right? So now we say our delta K formula is equals to half m v final squared minus v initial squared. Simple from here, we take our mass value, which is 5,900. You see the purple truck. And then we substitute our v final that we solved for, which is 9 squared minus the 0 squared. You put this into your calculator and you should be coming out to your value of your delta EK to be 238,950 joules. Can you please double check my answers? Someone give me
Yeah,
I got the same answer.
tackle 11.3, please read.
How much work is done by the friction force?
Okay, so now if we come back to our diagram, what do they give us? They give us the force of friction, which is 2,87 times 10 to the power 4 newtons, right? So that's what they give us. They give us our delta x, which is 360 meters. So in our work equation, we need three things. We need our force, we need our displacement, and we need our whether it's going in the same direction of motion or against the direction of motion. So here we see this thing here is going down. I didn't put an arrow, but it is going down. And the force of friction is going up the slope. It means that it's going to be a cos of 180 degrees. So if we take all of our data, plug it into the equation, we should be getting a work of friction of minus 10 million. Okay. Oh, so yeah, so our force of friction is what? 2,87 times 10 to the power 4. Our delta x, 360. Go back to our diagram. Is it 360? Yes. And then cos 180, opposing the direction of motion. That's why 180 will give us a minus 1 there. And then we should get a value of minus 10,332,000 joules. Please double check, please. Are you all fine?
I got to see.
11.4, please.
Can you just give me a second, please?
Yeah, no stress. Take your time.
Okay. How much work does the engine do while the truck is accelerating?
Okay. So now, this way here, we can do it in two ways again. But this time, I figured out how to do it my way. Super. So now, we need to find out what's the work of the engine. Our work of friction is what we calculated here in 10.3 minus 10,332,000 joules. Our delta EK is also what we calculated earlier on, which is 238,950 joules. And then we had our potential energy being 0 joules because why? It started at the 0 height. Therefore, we know our potential energy from the starting is 0. Then we have our final potential energy, which is 2.6 million joules. So that's all of our data. Now we can do this in two ways. You can do it either the WNC way, WNC. Okay, write down your data. I'm speed voting here. Okay. So now, can everyone try and do it the WNC way? I made a mistake here. Can someone please correct my mistake?
Final minus initial.
Okay. Please, can you repeat yourself?
It's final minus initial.
So is my answer correct? Can everyone just check? There's still something wrong, I guess. Can someone please correct my mistake?
I think the answer is 13,172,850. I don't know if I'm right though.
Okay, just double
I
check.
got the same thing. Jamil.
Okay, then my answer is right. In the third line,
Yeah.
the okay, wait, let me just read it. 238,950 plus 2,601,900. It's 2,840,850. It's positive.
I think it must be 0 minus 2601 and the mistakes on top by the data.
Yes.
Yeah, Newton is right. You must swap that and the answer is right.
Oh, okay.
Yeah. Just the data also.
Because it's final minus initial.
Okay. Do you want to try the W net way? Everyone try the W net way themselves, because that's the second way that the memo doesn't show. The memo's on the screen. Don't look at the screen yet. Everyone take this down here.
Yeah.
Yeah.
Is everyone ready to see the W net way?
Yeah.
Yes.
Now, for this question, you could use either of the two. This is the simpler way. It's not as mind-boggling. You don't have to scratch your head as much. This is the fun way. Now, the fun way, we have to take all of the work, our network, working on the entire system in proportion to our change in kinetic energy. So we have three forces acting on our diagram. If you come here, the one you can see, which is our force of friction. Then we have our FG parallel, which I didn't draw. Make sure you have it included if you do a free body diagram. Yeah, the FG parallel is basically it's parallel to your slope, going in the opposite direction of friction. So, and we have one more, which is our work from our truck itself, your applied work. Yeah, our work of engine. That's what it's trying to solve for. Okay, so now our work of friction, we calculated that earlier. You come here, you see what's our work of friction, minus 10,332,000. Our work of our engine is what we want. And our, oh yeah, sure, so don't forget. Oh, I'm adding it. Okay. So our work of engine is what we're missing. Now with this WFG parallel, usually people make big mistakes here because we think we don't have enough data when in actual fact we do. So if you look at this, what we need for our FG parallel, which is our weight times sine theta. Our weight is mg. Mg sine theta. But now you might be thinking we don't have an angle here. If you look at the question, we don't have an angle. But what we do have is our opposite and our hypotenuse. Just remember that, our delta y and our delta x. Come back here. We continue with our work equation, which is your force, which is our FG parallel here, multiplied by your displacement, multiplied by cos theta, which will give you our delta EK, which we also calculated earlier, 238,950 joules. Still can't solve for the work of the engine. We start plugging in values from the diagram. We have a truck that weighs 5,900 kilograms, gravitational constant of 9,8. Now this delta y over delta x, you can put in values here, but there's a nice thing that you can do, which is you can cancel out these delta x's, so it's easier to work with just that delta y. So it's easier when your calculator, you don't make as much mistakes. So if you leave like this, you cancel the delta x's, we'll just be left with our delta y. Then we have cos of 0 y, because your FG parallel is working down the slope. You take this minus 10,332,000 over, and you add it onto this 238,950, you'll get the total value there of 10,570,950. You plug in your delta y. Our delta y comes from our diagram. It tells us in the diagram and the question that the height of the slope is 45 meters, right? Don't forget to make your cos 0 into 1, right? Then this just becomes calculator work. You get the value for this entire bracketed part of 2,601,900. We still have our 10,570,950 on the other side. We take this amount over, we minus it from this 10 million amount, and we get it, your work of your engine, which is 7,969,050, which is the same as the one we got earlier. Just I didn't mess up this one, hopefully. You'll understand this way?
Yeah,
Yeah.
this one's better.
Which way is better?
First one.
Much easier. Okay. 11.5.
Calculate the power produced by the engine if the truck takes 80 seconds to reach the bottom of the slope.
Okay, so now what's our data? Do we have our power? Not yet. We do have our work that we calculated here. So we can put that in our data. And our delta T, they are telling us that it's going to be 80 seconds. Now we can use the simple formula, E is equals to W over delta T. The power is equals to your work over your change in time. Start plugging in your values, 7,969,050 all over 80 should give you a value of 99,613,13 watts. Can someone double check this for me, please?
It's right.
More confirmations?
Yeah, it's right.
Okay. Did everyone take this down?
Yeah.
Okay. 11.6, please.
At the bottom of the slope, the truck cannot stop and enters a gravel arrestor bed. The bed is 25 meters long and provides a resistive force of 0.25 times the weight of the truck. Will the bed be long enough to stop the truck?
Okay, now if you look at the question itself, they're telling us that this arrestor bed here at the bottom is 25 meters long. So that's our maximum delta x. You can't go over the delta x. For this equation here, for this entire question, they're asking to see how far does this truck travel before it comes to a stop. So now we are forced to solve for delta x. From our previous questions, we know that our v initial is equals to 9 meters per second, because remember at top it was v final, v initial was 0, then our v final here was 32.4 kilometers per hour. We calculated it, we changed it to 9 meters per second. How? We divided the 32,400 divided and divided 32,400 by 3,600. Okay, so now they also tell us that our resistor force is 0.25 times the weight of the truck. Our weight is mg. So now just make it easier for yourself. This is your force of friction, right? That's right. Force of friction is always bad because it slows down stuff, right? So we solve for that, but you can either do it now or you can do it in the actual step. So now if you look here, our force of friction, I told you earlier, was the red one, 0.25 mg. Will give us 0.25 multiplied by the weight of the truck, 5,900, multiplied by our gravitational constant, 9.8, which should give us 14,455 newtons. Right? Everyone understanding this first part? Everyone? Anyone?
Yeah.
Hey, can you
Yeah.
go to the slide before
Good.
this quickly, please?
Okay.
Okay, yeah, thank you.
So can we carry on with the sum?
Yep, thanks.
Okay. So now this sum here is fairly complicated. I'm not going to lie to you, Allah. Makes you think like you join the dots basically. So we know that we have an equation W net is equals to delta EK. Now W net only works with direction in a one-dimensional sense. If I'm right or wrong. Right? So now the only thing that's stopping, the only force of work that's stopping the struck is the force of friction, is the work of friction in a parallel plane. In a horizontal plane, my mistake. So our work of friction is 238,950. Right? So now WF is equals to F delta X cos theta. So now what are we trying to solve for again? We're trying to solve for this delta X. Right? Yes. Okay. So now we take in our values of our friction. We take our force of friction here, 14,455, 14,455, plug it into the formula, and plug in the cos theta value, which is cos 180 degrees. Why? Because it's opposing the direction of motion. Right? So now we get this cos 180 degrees to be our -1. You divide both sides by -1, this becomes a minus 238,950. Right? This is your coefficient of your delta X, the 14,455. You want to get this 14,455 out of there. Why? Because you want to get this delta X to stand alone, because that's what we're trying to solve for. Now you are going to get a negative answer, but since displacement is your distance cannot be negative distance, if I'm not mistaken, we get our delta X value to be 16,53 meters. So now if you look at the question, the gravel raster bed is 25 meters long, but the truck only traveled 16,53 meters before it reaches a stop. Right? So that is why the truck will stop.
AK,
Yeah.
mustn't the 238,950 be negative?
Yeah, I think so also.
Yeah. So then you won't end up with a negative answer for delta X.
Okay, please tell them why that our work of friction must be negative.
Not friction. Delta EK.
Yeah.
Oh yeah. Because the final is less than the initial. So you get 0 minus 238,950 is equal to minus 238,950.
And better we graph it, and this is 0 minus 238,000. Thank you, Shape. Okay. Kamala, you fine?